Today we're going to work on this 2012 Audi A5. It was brought to me because the AC is not working, so he wanted me to check and see why that's going on. And I already scanned it, and it's pretty much looking like it could be pretty straightforward, but there's just a couple things you want to double check before making a call. So just going to bring you along and show you what are some of the things to check on this model. So first things first, on a vehicle like this, you want to make sure you scan all modules. And I am actually in the air conditioning control unit, and it does have a trouble code for activation of the AC compressor. If you go further into information, it refers to possible causes, and one of the things to concentrate or look at is this N280 valve. Basically, this compressor does not have a clutch. It just has a regulating valve that is pulsed dependent upon the demand that the module is asking for out of the compressor. That's how it controls the pressure on the compressor. So there is a 2-wire solenoid valve at the compressor, and that's all. And obviously we can have other things that could be the problem, but I am actually tapped in to that solenoid valve on the scope, and I will show you on the scanner compared to the scope. So we'll start the vehicle. There is refrigerant in the system. This vehicle came from another shop, which they replaced the pressure switch with no result, so they brought it to me. I know there is refrigerant in there. The data you want to look at, since we are going to concentrate on that valve, is that N280, and look at the pressure as well. And right now the climate control is off, but I will let's see, we'll turn it on, and still nothing on the scanner until I hit the AC command, and you watch the PIDs. So that's amperage that it's reading. The pressure did not change, and if you look at the scope, that red trace went up to source voltage. That's constantly on, 100%, which matches this being constantly on, but we are seeing no change in pressure, and we obviously don't feel any cold air. It is beginning to look like it is the regulating valve. It will turn off, and then the red did go back down to 0. With that on the scope and this being seen here, I believe everything module wise and requests and stuff is working properly. Now it's time to go look at the regulating valve. Okay, we've recovered the refrigerant, and just to show you, 1.15, and it calls for about 570 grams, which when converted, we are pretty much right about there. Just to get you a shot of where I was tapped in at, was the 2-wire connector to the solenoid valve, which that's your solenoid valve. I will go ahead and remove it and inspect it. So there is the housing in the compressor where the valve lives. Here's a shot of the valve. It's just a solenoid, kind of like a variable cam solenoid or solenoids and transmissions. Nothing crazy or special. And I was going to put it on the bench to test with 12 volts, see if the spool valve inside moves. But just as I was doing that, look at those pins. They both have been bent over towards the connector housing. They're not sticking up straight. Someone has goofed that up, and now the 2-pin connector is not making a proper connection. What I'm going to do is bend those back straight, make sure connector fits in there well, and then go from there. Well, not sure if you can see good, but there are the pins straightened out. So we'll see what we get. So actually, now that I've straightened out the pins, before I go ahead and waste my time and put it in the car, I've got it still set up to test on the bench with the power supply, and then I'm hooked up to the scope with the amp clamp, and then the voltage trace as well. And I will do a quick activation. Actually, I'll get you close enough to okay, so you can hear it, and there is the pattern that it's created. So here is a zoomed in example. Here is your amperage, and there's your voltage. And also to check on the amperage for the solenoid, you can tell that it's not shorted because it has a ramp and doesn't go straight up like a shorted winding, as you can see there. So as far as this valve goes, I'm betting it's actually good and operational, and probably be confident enough to put it back in, and maybe it's just a no pin contact issue. Now just some more verification based off of numbers, since this is a simple circuit, other than what we did see with the scope while activating it. We're going to just do a simple Ohm's law check and verifications. I am tapped in, just reading the resistance, which is 11.1 is what we're getting. And then based off the other two numbers, the voltage and amperage. So voltage is 12.29 and the amps is 1.098. Just for, like I said, playing around. The way that I learned to do or figure out my Ohm's law is to draw a circle, a line, and a line. E stands for electrons, which is voltage. A is amperage. R is resistance. Another way that was easy taught is just by the word ear and spell it out, E-A-R. So you know that the order is going to be E-A-R, electrons, amperage, resistance. The lines here signify the top and bottom. Any of these would be division, and this way would be multiplication. So you can multiply these two to figure out that. You can divide this by this, figure out that. You can divide this by this, figure out that, and so on. So that's how it works for me, or how I learned it. We know we're going to play around with the electron or voltage, 12.29. Divide that by 11.1. So 12.29 divide 11.1 equals 1.10. So that's pretty much there when rounded off. So we know based off a simple circuit that this seems to be correct as far as operation. We can audibly hear it. We can see the pattern here on the scope. and even basic ohms law numbers work out. Now I will put this in the car and see what it does. Okay, so we'll go in and we'll clear the trouble code before anything. Okay, cycle the key. And before we start, I do have a temperature probe in there just to be able to see physically the temperature change if it all works. I don't have the scope hooked up. I believe the live data is going to be well enough. Okay, so we will start the car. Okay, no AC button yet. So now, and there is your pressure change, and both amperage ones are changing, and temperature is dropping. So that is all that it took on this one. Bad connector messing up the valve, and not much more after that. Alright, so this one is all done. Nothing too crazy. Obviously no new parts needed. Just basic test and checking procedures. Just again remind yourself to do your visual inspections, check your system. Obviously off camera I read about it and how what's comprised of the system, how it operates. Once you know that ahead of time, you can have a path to follow. In this case, based on the trouble code, it seemed like it was going to be down at the compressor with the valve, but by going to the point where you remove the valve and decide to bench test it, if I never would have done that, I never would have found the bent pins in there, and I could have basically made a call on the compressor, because that's how you get the valve. I know aftermarket wise some offer it, but time frame on that compared to an available compressor, the difference there. You make a call on a compressor, you put it in, it's going to work as long as that connector, if the connector was not the problem, which was messing up the pins, you could end up fixing it, or you could make a problem on a new compressor if the connector's the problem. So if you would have fixed it, you never would have known it was the pins. If it damages the new compressor, then you're stuck again trying to figure out what's going on. Just the power of visual inspection and the basic testing procedures is what can allow you to make correct calls and fixes. Don't be too rushed. Take your time and try not to miss basic stuff. Hope this was information that was useful, and customers gonna be happy with them. Just some diagnostic time, procedures, and repairs. No parts needed. Everything is good and blowing cold now.